Do you know what the lowest temperature ever created by humans is? It is minus 273.14999 degrees Celsius, only 1/10 billionth of a degree away from absolute zero. But that final 1/10 billionth is something humanity can never cross. This is not a technical limitation, but a rule of the universe. Einstein says no, quantum mechanics says no, and the third law of thermodynamics has already sentenced it to death. Why? Because reaching absolute zero would require infinite energy. Burning the entire sun would not be enough. But scientists refuse to accept this. They used lasers, magnetic fields, and all kinds of unimaginable methods to gradually push temperatures lower and lower. And what they discovered was a world that overturns our understanding. In that world, gases become a fifth state of matter. Atoms begin to act collectively, and the laws of physics start to break down. Absolute zero becomes the only window for humans to glimpse the true nature of the universe. So the question is, how was the value minus 273.15 degrees actually calculated? Did anyone ever really measure it? The answer is no. This number was derived mathematically. In 1802, a French chemist named Gay-Lussac conducted a simple experiment. He placed gas inside a graduated container and continuously cooled it. He discovered a pattern. For every degree of temperature decrease, the gas volume shrinks by 1/273rd. This implies that if cooling continues to minus 273.15 degrees, the volume of the gas becomes zero. But how can volume be zero? Matter cannot simply disappear. So this temperature represents the limit of the universe, the end of temperature itself. Later, it was named absolute zero. But there is a deeper question. What is the essence of temperature? The answer is particle motion. You feel heat because atoms vibrate violently. You feel cold because atomic motion slows down. Absolute zero means atoms completely stop moving. Everything becomes still. Everything falls into silence. Sounds simple, right? But here lies a huge contradiction. Quantum mechanics tells us that particles can never be completely motionless because of the Heisenberg uncertainty principle, which states that you cannot precisely know both the position and velocity of a particle at the same time. If a particle were completely still, its velocity would be zero and precisely known, which violates quantum laws. Therefore, even at absolute zero, particles still possess a residual motion called zero-point energy, like a person whose heart continues to beat even while asleep. The universe does not allow absolute stillness. So how close can humans actually get? In 2021, German physicists set a record by cooling a quantum gas to 1/38 trillionth of a degree above absolute zero. How did they do it? They dropped gas inside a 120-meter tower and used freefall to create weightlessness, repeatedly turning magnetic fields on and off, so the gas barely expanded at all. The temperature became so low that atomic motion was 1 trillion times slower than a crawling snail. Yet even then, they still did not cross the red line. This raises another question. Why does temperature have a lower limit, but no real upper limit? The highest possible temperature in the universe can reach 1.4, multiplied by 10, to the power of 32 degrees, known as the Planck temperature, while the lowest is only minus 273.15 degrees. The gap is unimaginably vast. The reason is simple. High temperature means particles move faster, but there is a speed limit, the speed of light. Low temperature means particles slow down, but absolute stillness is the limit of zero, and that limit cannot be exceeded either. However, the distance between speed of light and absolute rest is inherently asymmetric, so the temperature range of the universe has never been symmetrical from the beginning. Now let's consider a terrifying scenario. What would happen if your hand touched a piece of metal at absolute zero? First, you would not feel cold immediately because nerve signals take time to transmit. But before you even react, destruction would already begin. The skin on your fingers would freeze within fractions of a second. Water inside cells would instantly crystallize into countless tiny ice shards that tear cell membranes apart like blades. Blood vessels would contract violently, cutting off circulation, and tissues would rapidly die. You might hear a sizzling sound, like steak hitting a hot pan. But this time it is not heat, it is cold. Your skin would stick tightly to the metal, like a tongue, on a frozen pole in winter, except the pain would be 10,000 times stronger. The more you try to pull away, the worse the tearing becomes. By the time you reach the hospital, doctors may tell you the hand cannot be saved. Yet within this terrifying extreme cold lies one of the most fascinating secrets of the universe. In 1995, 3 scientists won the Nobel Prize for an experiment in which they used lasers and magnetic fields to cool rubidium atoms to 170 nanokelvin, above absolute zero, 1/10 millionth of a degree. At this temperature, they observed a new state of matter, Bose-Einstein condensate, predicted by Einstein 70 years earlier. In this state, atoms lose individuality. They are no longer separate entities, but become a single unified quantum system, behaving as if thousands of atoms were one. It's like students running randomly on a playground, suddenly hearing a command and standing in perfect formation. Even more astonishing is superfluidity. In 1938, scientists discovered that liquid helium at minus 271 degrees becomes a superfluid with zero viscosity, capable of climbing container walls and flowing out on its own, passing through any tiny gap. In 2024, scientists achieved another breakthrough when researchers from the United States and the Netherlands cooled NASA molecules to near absolute zero, creating a molecular Bose-Einstein condensate in which over 1,000 molecules entered the same quantum state. This suggests that in the future we may develop zero-resistance superconductors and ultra-fast quantum computers, meaning extremely low temperatures are opening a new technological era for humanity. But did you know that the universe itself contains a natural freezer called the Boomerang Nebula, located 5,000 light-years from Earth, with a temperature of about -272 degrees, just 1 degree above absolute zero? It is even colder than the cosmic microwave background radiation of the Big Bang. Why? Because it is gas ejected from a dying star, expanding outward at high speed, and as it expands, it cools continuously with no external heat source, making it colder than the rest of the universe. This is a natural ice chamber, created by the cosmos. At this point, we must mention a more terrifying theory, the ultimate fate of the universe. Scientists predict that in about 10 to the power of 100 years, the universe may undergo a big freeze. All stars will burn out, no new stars will form, black holes will slowly evaporate, and eventually disappear. The universe will approach absolute zero. All atoms will stop moving. All chemical reactions will cease. No light, no heat, no motion, no change. Time itself loses meaning, because nothing happens anymore. Entropy reaches its maximum, yet everything becomes frozen, in perfect stillness. This is the true horror of absolute zero. It is not just a temperature, but the endpoint of the universe, the opposite of existence, the tombstone of time, and the forbidden zone of life. Yet humanity has never been a species that gives up. In 2025, Chinese Academy of Sciences researchers discovered a new material, potassium hexafluorophosphate, which enables cooling from room temperature down to near absolute zero, meaning future refrigerators and air conditioners may no longer need compressors. Meanwhile, cold atom laboratories aboard the International Space Station are attempting to create the coldest matter in history, taking advantage of microgravity to reach lower temperatures and maintain them longer. Every step closer to absolute zero reveals more of the universe's underlying code. Some say absolute zero is an unreachable end for humanity, but perhaps it is precisely because it is unreachable that the pursuit becomes meaningful. Like Sisyphus pushing the stone uphill, knowing it will roll back down, we still keep pushing. We know we will never reach absolute zero, yet we continue to approach it degree by degree, because along this path, we have discovered new states of matter, superfluids, and the secrets of quantum physics. These discoveries are transforming our lives. MRI requires superconducting magnets. Superconductors require extremely low temperatures. Quantum computers require chips cooled to millikelvin levels, and future interstellar travel may require cryogenic preservation of the human body. Every step closer is a challenge to the forbidden zones of the universe. So how terrifying is absolute zero? It is so terrifying that it can freeze light, freeze time, and freeze all possibilities. It is both the end and the beginning, both death and rebirth, a forbidden boundary humanity can never touch, and yet also a star we will never stop chasing.